On this video, we're going to talk about Euler's method. So you recall that delta y over delta x is dy over dx. If you solve for delta y is going to be dy over dx times delta x. Now, why is Euler's method so useful? Let's say you have an original curve, and you know that there's a point x comma y. So let's say you want to approximate another point using dy over dx. So let's say there's another point over here. Now from here to here, using linearization, you know that this is delta x and that is delta y. So the new point is going to be x plus delta x comma y plus delta y. And we know that delta y is dy over dx times delta x. And we could keep going using the same process and eventually approximate the value of y of the original curve without knowing the equation of the original curve. And this is a power of Euler's method. And we're going to look at some examples. So let's take a look at an example. Let f be the function that satisfies the initial value problem. dy over dx equals x plus y, and f of 2 equals 0. Use Euler's method and increments of delta x equals 0.2 to approximate f of 3. So basically we have an initial value, which is when x equals 0, when x equals 2, y is 0. Okay, so we're going to add delta x and delta y to get the next value. But remember, our goal is to find what is the value of y of the f when x equals 3. Notice, we're starting when x equals 2, and our delta x is 0.2. So dy over dx is x plus y, where our first x and y value is 2 and 0. So that's going to be 2. Again, 2 plus 0. What is our delta x? It's always going to be 0.2. It's given, at least for this example. Now, what is our delta y? Delta y is going to be dy over dx, which is 2, times delta x, which is 0.2. So what is that? That is going to be 0.4. So what is our next point? Well, that's x plus delta x, which is 2.2, comma, y plus delta y, which is 0 plus 0.4. So now that becomes our next point, 2.2, comma, 0.4. Okay, you need to repeat this process until you get to x value of 3. So let's do it. What is our dy over dx? It's going to be x plus y, which is 2.2 plus 0.4, 2.6. Again, delta x is 0.2. And then it's going to be 2.6 times 0.2, which is going to be 0.52. So our next y value is going to be 2.4. I got that from 2.2 plus 0.2, comma, y plus delta y, which is 0.4 plus 0.52. That's 0.92. Okay? So, and then our next point is 2.4, comma, 0.92. And then our dy over dx is going to be 3.32. And that stays the same. Delta x stays the same. And then our new delta y is going to be 0.664. And what is our new point? It's going to be 2.6, comma, 1.584. Okay? What about our next point? It's going to be 2.6 and 1.584. So our dy over dx is going to be 2.6 plus 1.584, which is 4.184. Then 0.2. Our new dy is going to be 0.8368. And our new approximate value is going to be 2.8, comma, 2.4208. All right, we have one more step to go because we need to approximate the y value when x equals 3. So we're almost there. So this is going to be 2.8, 2.428. And our new dy over dx is going to be 5.2208. And then our new delta y is going to be 1.04416. And finally, we get 3, comma, 3.46496. So, what is f of 3? Well, f of 3 is approximately 3.46496. Now, again, the beauty of this is that we didn't know what the original f was. We just used dy over dx to approximate the value of f of 3 using Euler's method. On this example, they don't give us what delta x is. But it does say that use 5 equal steps to approximate y when x equals 1.5. So basically, we got to approximate f of 1.5. But what is our delta x? Well, the initial value is 2, 3. Okay, so original x value is 2, and we want to get to 1.5. So we're starting from 2, and we want to get to 1.5. So obviously, you could tell that delta x is going to be negative. So what is 2 minus 1.5? That's 0.5. And we're using 5 equal steps. So 0.5 divided by 5 will be 0.1. But notice, in order to get from 2 to 1.5, delta x has to be negative 0.1. So that is going to be our delta x. So once you have a delta x, setup is pretty easy. Again, you start from x comma y, and you know that dy over dx is, in this case, 2x minus y. Delta x in this problem will be negative 0.1. What about delta y? Delta y is going to be dy over dx times delta x. And your new point is going to be x plus delta x, comma, y plus delta y. So what you want to do, you want to start from 2, 3. Okay, plug it in to get the dy over dx, and then you get delta y, and then you add those new delta x and delta y to x and y to get the next value. And you have to get to where x becomes 1.5. It's a little tedious, but you could do it.